Okay, teachers, I am doing this multiplication fluency assessment with Sophia now, okay? Okay, Sophia, what is 0 times 4?
0.
Yeah, see, you don't need to be nervous, do you? What is 10 times 7?
70.
7. What is 5 times 3?
50.
What is 2 times 6?
12.
What is 4 times 8? Take your time.
32.
Oh my goodness, how did you get 32 so quickly?
Because I know when every single time when we do rotations, I've learned how to do trash, and I got so used to it that I remember how to count lights.
Oh, so you counted by eights. Did it sound like, what did it sound like? Did you start at 8, 8?
16, 24, 32.
Awesome. Okay, what is 8 times 6?
48.
It is. Did you start at 32? You remembered that 4 eighths was 32, so you just did 2 more eighths? Wow, I heard that. What is 3 times 9?
29.
Okay, how did you get 29? Tell me.
I think it is because I know that 10 times 3 is 30, so...
No, did you hear that, camera? She knows that 10 threes is 30. So what would you have to do next?
30 take over 9 equals 29.
Okay, okay. I see, camera, I know what to do next. This excellent young lady is trying to use the tens strategy to figure out her nines. And so I would recommend using 10 frames in your classroom. I'm sure we've shown these pictures before, but if you don't have these, there is a Google slideshow that's called 10 frame multiplication subitizing. You can get that from me if you want to. So 10 times 3 is 30. And most kids want to use this strategy, they're just not sure what to use next. However, if you will flash the 10 times 3, most kids will go, it's 30. And they'll say, because I saw 10 threes. They're used to 10 frames when they come out of second grade and first grade and kindergarten. And so then what you want to do is tell them that you're going to flash the next slide. Well, the next slide is 9 times 3. And when it comes on the screen, the kids are like, whoa, what just happened? But they realize that they took 3 away. And that's something that little girl was struggling with. I think she was taking 1 away at one point, but then when she was also trying to take 9 away. But this image very much shows you that you take 3 away because you had 10 threes and now you only have 9 threes. Try this with your kids so they use this strategy correctly. Okay, what is 7 times 8?
56.
Did you just add another 8? You remembered. Awesome. 9 times 6. 9 times 6.
We just had that one. Oh, no, that was 18.
Ooh, ooh.
59.
How did you get 59?
I did the same strategy for 9 times 10.
Oh.
I meant 10 times 6 equals 60, so 60 taking 9 is 59.
Okay, okay. What is 4 times 4?
15, not 50,
Okay,
or 20.
okay. Take your time and figure that out. How are you going to do that?
Sixteen.
16. And did you skip count by fours?
Yeah.
I saw you do that. That's good. Okay, what about this one? 3 times 7.
15. Oh, 21.
You almost knew that one, right?
Yeah.
21.
I'm,
What? Go ahead. I'll listen.
I'm kind of used to that one, but I just haven't done that one in a while, and then I was about to skip that, but then I remembered, oh, I just need this one and that one. So it's 21, and if we would do 4 times 7, it would already be 28.
Okay, well, guess what I'm going to do? I'm going to not do, I'm going to keep you 3 times 7 is 21. Don't forget that, okay? So if you know 3 times 7 is 21, what is 6 times 7? Can you use this one to help you do this one? Okay.
I could do 27, wait, 27, yeah, like 28. Then it would be 36, 32. It would be somewhere around 40.
Somewhere around, oh,
I could do, could do 10 times 6, and then I could just take like 2, 20. 60, so go 20, 40.
okay. I saw what you did. Okay. Okay, wait for it. How many do you see? Did you see 60? 10 sixes is 60. Okay, wait for it again. How many do you see on the next slide? Here it goes. How many did you see? Did you see 9 sixes? So hopefully kids will be able to see that there's 10 sixes, and then if you take away 6, so 60 take away 6, that's only 54. 9 sixes is 54. Seven times 5. Can you tell a multiplication story about that? Go ahead.
There are 7 boxes of markers. There are 7 boxes and 5 markers in each box. The teacher wants to give it to all 7 groups. Wait, I just don't remember. Oh, how much? And she wants to know how many total, if it's all even.
Okay. If they all get an equal number?
Yeah.
Great. And how many is that? What is 7 times 5?
I know 35.
Yeah. Nice job. Okay, you were perfect, kiddo. Okay, in my opinion, I think this girl is a 2. I definitely don't think she's below basic because she does know multiplication. She just doesn't have her facts quickly. However, she's using some strategies. She knew 5 out of 12 of the problems quickly. She found some of the answers using another fact, so she understands the distributive property, putting things together in her head. She tried to use the 10 strategy, she just didn't get it quite right. She did still skip count for some, which we'd rather them know them quickly. She needs some work on multiplication stories is another one of her weaknesses. This is Calissa, camera, and so I'm going to do the multiplication fluency assessment with her. And this is what it might sound like. So here we go, Calissa. What is 0 times 4?
0.
So I'm just showing her the cards, but I'm not going to show the camera because I'm going to say them. What is 10 times 7?
70.
70. What is 5 times 3?
15.
What did you just do in your brain to think of that?
Well, what I did in my brain is that I switched the 2 numbers around. And I did 3 times 5. And I know that 3 times 5 is 15. And then I know that 5 times 3 would be 15.
Awesome. I see what you're saying. Did you have to go like this in your brain? Did you go 5, 10, 15? Or did you remember it once you flipped it around?
I remember this.
Okay, awesome. What is 2 times 6?
Well,
What is 4 times 8? Take your time.
$48.
48. Tell me what you did to get 48.
Well, what I did in my brain is that I split the 4 into 2 and 2. And I know that 2 times 8 is 16 and 2 times 8 is 16. So then I added those two together and it got me 48.
Okay, so you added 16 plus 16. Will you add 16 plus 16 again? Will you do that for me?
Yeah.
What's 16 plus 16? Do that one more time. You got 48? How are you adding 16 plus 16?
Well, how I'm adding it is that since I have 2 tens at the beginning, I added those two, which gets me 20. But then 8 plus 8 is 16.
Are you adding 6 plus 6 or 8 plus 8?
Oh, 6 plus 6. 6 plus 6 is 12. So then I added the 12, the 10, and then it got. Oh, now I realize it's 42.
You think it's 42?
Uh-huh.
Okay, we're going to talk about that later.
Okay.
I don't think it's 42, but we're going to keep going. Okay? Okay, 8 times 6. 8 times 6.
It's 48.
It's 48. How did you get 48? What did you just do?
Well, what I did is I switched the two numbers around.
You did 6 times 8? Okay,
And I
and
know 6 times 8 is 48, so that's how I got my answer.
it took you a little bit to get 48 though. So what did you do? Did you count?
I skip counted. Well, after I switched the two numbers around, I broke apart the 5 from the 6, and then I added, then I did 8 times 5, which makes it 40, and then I knew that 1 times 8 equals 8, so then I added those two numbers together, which I got 48.
Nice. I understand what you're doing. So you did 5 times 8 first and then added another 8. Awesome. I like how you're thinking. Okay, what is 3 times 9?
$27.
27. How did you do that one?
Well, if I knew that 2, since I knew that 2 times 10 equals 18, I added 1 more 9 to it, so that makes it 27.
Awesome. And I think she counted by 1. So she got 18 and then you went 19, 20, 21, 22, 23, 24, 25, 26, 27. Okay. Awesome. Okay, you're doing great. What is 7 times 8? It is 56. What did you do?
Well, if I knew that, I know that 6 times 8, or 8 times 6 equals 48, then I add 1 more 6 onto it, it will make 46, 56.
Did you add one more 8?
Yeah.
I think you added one more 8, not one more 6.
Yeah.
That's okay. I know what you're saying, actually. What is 9 times 6?
52.
52. What did you do?
Well, what I did is that if I broke apart the 9 first, and then I had 4, so I knew that 4 times 6 equals 22, and then I did 9 times, then I did 5 times 6, which gets me to 30, then I added those two numbers together, which got me 52.
I love that. I'm surprised. So 4 times 6. Try 4 times 6 again. I think you made a mistake when you were figuring out 4 times 6.
Oh, wait, it's 24.
It's 24. Yeah. So it'd be 54, but that's okay. The one thing I'd want to say to you, Calissa, is when you did 4 times 6 just now, earlier when you did a 4 times something problem, you did 2 times 6 and 2 times 6. What is 2 times 6?
12.
So what is 4 times 6?
20, 24.
24. Yeah. So sometimes you use strategies, but you don't use the strategy again. So you should use that doubling strategy because that works for you, I think. The other thing I thought you would do 5. I thought you'd break apart the 5. I thought you'd do 5 times 9. Do you know 5 times 9?
Yeah.
What is it?
5 times 9 is 45.
It is. So if you know 5 times 9 is 45, what would you need to do next to get 6 times 9?
So add 1 times 9, which makes it 9.
Yeah. So we'll stop there, but that was awesome. Okay, let's try another one. What's 4 times 4?
16.
16. What's 3 times 7?
21.
21. What did you do?
Well, I broke apart the 7 and I did 5 times 3, which equals 15. Then I added 2, which I know that 2 times 3 equals 6. And I added those two numbers together. It got me to 21.
Equals 21. Hey, would it have been easier to do 2 times 7 and then add another 7? Okay. Little thinking, just little things of thinking, right? Okay, now, so 3 times 7 is what?
21.
21. If you know that 3 times 7 is 21, Calissa, what is 6 times 7? Can you use this one to help you get this one? Tell me what you're doing out loud.
Well, what I'm doing that if I break apart the 6, I'd have 3 times 7. If I knew that equals 21, then 3 times 7 equals 21. Then I'm going to add them together, which is 1 plus 42.
42. Nice job. You saw that they can just double, didn't you? That was awesome. Okay, last problem, Calissa. Can you tell me a multiplication math story about 7 times 5?
Lily has some candy.
Okay.
She puts the candy into 7 groups of 5. how much candy does Lily have?
Awesome. Love it. Okay, that's all. In my humble opinion, I still think this girl is also a 2. Even though she had a lot more strengths with her strategies, she still needs a lot of work on addition. So we need to build up students' addition strategies so that they can do multiplication better, which is why we're trying to work on that harder in first and second grade. But you can see here why that matters so much. Okay, teachers, if you're watching this, you are watching Carter and I do the multiplication fluency assessment, and I'm going to see what Carter knows. And I know you can't see our mouths, but that's okay. So here we go. I have printed out the cards that go with the assessment. And when you're doing this with your kids, you'll probably write at the same time because you won't have all the time like I do to go back and look at it in a second. But I'm just going to demonstrate what it would sound like. Okay, here we go. Carter, what is 0 times 4?
4.
4. What is 10 times 7?
70.
70. What is 5 times 3?
15.
15. Oop. What is 2 times 6?
12.
Okay. What is 4 times 8?
32.
Whoa, you just know all these. How do you know all these? You've just remembered them, haven't you? Ignore the 1. What is 8 times 6?
48.
Yeah, it is 48. 3 times 9?
27.
27. 7 times 8?
56.
Whoa! I did not expect this. 9 times 6?
54.
You're right. Now I heard him whisper to me something. Not to me. He was thinking. Did you do 9 times 5 first? And so what did you remind yourself of? Say it out loud.
9 times 5 is 45.
Okay. And then because you knew 9 times 5 was 45,
9
how did...
times 6 would be... I just forgot.
That's okay. Figure it out again. No big deal.
54.
54. And what did you do to get the 54?
I do 9 times 5. And I added 1 more 6. 1 more 9.
You added 1 more 9. Okay, awesome. I know he's thinking about that in his brain. 4 times 4?
16.
16. 3 times 7.
21.
Okay, now this is the one question, teachers, where you're looking for them to form a relationship. And he's already showing me that he has a little bit of that in his brain, but let's see if he knows this one. So 3 times 7 is 21. He's already told me that. Hey, Carter, can 3 times 7 help you solve 6 times 7? Not sure you see a relationship there? Do you know 6 times 7? Figure that out.
42.
It is 42. So if you know that 3 times 7 is 21.
Yeah, I can't help you because you have to double it.
Oh, he said it can help you because you have to
Double 3 times 7.
double 3 times 7. So he saw the relationship after the fact, which is fine. Okay, so that's what I did. I held him like this for him. So after he told me this was 21, I put the 6 times 7 under it and I said, can you solve 6 times 7 using 3 times 7? Okay. Okay, and this is the last one. Can you tell me, this is 7 times 5, teachers? Can you tell me a story about 7 times 5? Can you make up a multiplication story about 7 times 5? Take your time.
Lucy went to the store every day of the week and she bought 7 apples. And at the end of the week, she had how many apples?
Awesome. So you're thinking that the week is 5 days, and she bought 7 apples every day, and so 35 apples.
It pretty much be 5 times 7.
Oh, that would be 5 groups of 7. So he actually knows the difference. That's awesome, but I'll still accept that, okay? Okay, and then the last one, Look at this one again. 0 times 4. You said 4 the first time. Do you remember saying that?
Yeah.
Okay, so you know it's 0. Carter, you were amazing. Thank you so much. Okay, teachers, I know this is the hardest part. I think I would call this boy a 3. He knew most all of them quickly. The only one he struggled with was 9 times 6, but he was using a strategy, so he's super flexible in his thinking, and he did it in 5 seconds. It sort of bothers me that he didn't see the double relationship right away, but we need to do more of that in our classrooms. So I know that's something he would pick up, or I'm pretty sure he would pick this up quickly. If you've watched all of these and you need more help, let me know. If you'd like me to watch you give one, let me know. I'd be happy to help. I am going to attach these 3 assessments to the email when I send you so that you can look at my notation on each kid's assessment so you can see what I wrote down. Have a great day. Good luck with multiplication.